All right, question 6 in your FRQ packet. This came from the 2018 scoring guideline, or from the 2018 exam. So Google AP Statistics 2018, go to question 2. Question 1 was a regression question, but we already did that one. So if you want to review it, you can. But we're not going to do it again since we've already done it. Hopefully, I didn't make any dumb mistakes on this question. Part A, so an environmental science teacher at a large high school like ours asks, randomly selects a sample of students, that's good. Each selected student who went into the teacher's office one at a time was asked to respond yes or no to the following question. Do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval for the proportion of all students at the school who would respond yes to the question was calculated as 0.584 to 0.816. How many students were in the sample selected by the environmental science teacher? So first of all, I needed my sample proportion, which remember is directly in the middle of my confidence interval. Then I need my margin of error. So I chose to set up the whole equation like this with the plus using my upper bound. But I also could have started with 0.816 minus 0.7 and gotten my margin of error is 0.116 equals 1.96 square root of p times 1 minus p over n. I solved the rest of my arithmetic, got 59.9536, which is equal to 60 students. Oh, thank God, that's what they got. Let's look at the scoring. Essentially correct if they use the standard error in this format with a p-hat between 0 and 1. So I did use that format with a p-hat between 0 and 1. Shows evidence that 0.116 was calculated, used as the margin of error in the calculation. Shows evidence that 1.96 was calculated, shows evidence that 1.96 was correctly used as the critical value in the calculation, includes a single positive whole number answer. So you didn't actually have to have all the arithmetic correct. Those 4 things. Oh, shows that 0.7 was used as well. So had all the right setup, ended up with a positive integer answer, was essentially correct. It doesn't even say it has to be right. Partially correct if the response satisfies only 3. Yeah, and just includes a single positive whole numbered answer. Interesting. Cool. So you need all 5 of those components to get an E. 3 or 4 of the 5 gets you a P. I is incorrect. Note that using an equation in this form where you've already solved to get n by itself is also acceptable. A value of 0.21 in the numerator of the standard error implies that 0.7 was correctly used and satisfies component 2. An equation such as this one, 0.816 equals 0.7 plus the margin of error, that's what I did, implies that 0.116 was correctly used. So even if I had jumped straight from here to the answer, I would have gotten credit for the 0.116. Statements that suggest a whole number is approximate, such as about 60 or approximately 60, satisfy component 5. Algebraic work between the setup and final answer does not need to be shown to satisfy component 5. When calculating the values of 0.7, 0.116, or 1.96, ignore minor arithmetic errors or transcription errors if they can be identified by the workshop. So I'm not sure if your final answer has to be consistent, but it doesn't say it does. So I assume that we're good as long as we have all the setup correct and an integer final answer that's positive and whole number and greater than 1. Section 2, or part B, So part B had some sampling design in it. Given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how bias might affect the point estimate of the proportion of all students at the school who would respond yes to the question. So I said the students were being surveyed by the environmental science teacher in person. They might have been embarrassed to tell her they don't recycle, so they lied and said that they did. They said bias might have been introduced because students responded directly to the environmental science teacher. Because the students would know that the environmental science teacher cares about the environment, they might say yes when they actually don't recycle. This would result in a point estimate that is greater than the proportion of all students who would respond yes. Okay. Both good answers. Let's see what the scoring guideline says. Essentially correct if you have the following three components. Explains why the response to the survey might differ from the truth about students recycling in this context. So why? Because they might have been embarrassed to tell her they don't recycle. Because they thought that she would really care about recycle, so they lie. Something like that. So why did they lie? Explain how the responses to the survey might differ from the truth about student recycling. For example, students might say yes when they actually don't. So they lied and said they did. So students might say yes when they don't actually recycle. Students lie and say yes. Students don't recycle but lie to the teacher. Something like that about how their answers would be different from the truth. Describes the effect of the bias on the point estimate or the proportion / percentage, number of yes responses in the sample, etc. And doesn't contradict the bias described. So we're describing an over that we think it's too many. Oh, did I not do that? So the point estimate will be higher than the actual population proportion. Or so more students will say yes than actually should have. They might have been embarrassed to tell her, so they lied and said that they did. Not sure if that counts or not. I would rather underestimate my score so that I overcorrect and make sure I have it next time. So they might have been embarrassed to tell her they didn't recycle, so they lied and said they did, meaning the point estimate will be higher than the actual population proportion. I'm going to give myself partially correct here. To satisfy component 1, the response must provide a response that is based on a bias created by the teacher asking students in person. A response that addresses wording of the question, voluntary response, or sampling variability does not satisfy component 1. To satisfy component 2, the response needs to explicitly contrast what the students say with what they do. So they lied and said they did. Lying implies that that's not the truth, so I have that. Evidence used to address component 3 cannot also be used to address component 2. For example, a response that says students might lie, producing an estimate that is too high, addresses the effect of the bias on the point estimate, but should not be combined with the statement about students lying to infer that students do not actually recycle. However, a response that says students may lie and say yes, producing an estimate that is too high. Okay, So students may lie and say yes, producing an estimate that's too high. But just students might lie, producing an estimate that's too high. They might lie and say yes. But I didn't have anything about the point estimate being too high. Okay, I think that covers the main points in those notes. So you should be able to determine what your score was. Part C. Essentially correct. The response gives an answer of 150 in CI and gives it an answer of 0.58 in CII. Or equivalent. Yes. So I have that and I have that. So that's essentially correct. I did fall for the trap though the first time I did this question, and I almost did here, where I did the proportion who would say no. So basically we take that 150 students out because those are the students that had to say no. So we just remove them altogether from both the sample and the people who said no. And then we use that to figure out how many people actually said yes, like truthfully said yes. Partially correct if you got the 150 correct, but then you gave an answer of 0.42. This is 0.42. If the response does not give an answer of 150, but gives an answer of 0.58 with supporting work and CII. So I think it would have been much more likely that you missed this one, but not that one. Incorrect if you didn't get either of those. I think that we don't need to go over any of those notes. Okay, so this is a 3-parter, so I assume 3 out of 4, but I don't feel as bad about that one. But I will learn from that, and I'll make sure that next time I talk about the actual population proportion. Okay, you can read.